Thank you for doing that. All right, so now we rocked out the phosphagen system. We've talked about fast glycolysis. Now let's talk about slow glycolysis. And in the effort to really talk about slow glycolysis, we need to remind ourselves, whenever you burn glycogen, you get pyruvate. Pyruvate couples with some other cool ions, and you end up with this magic substance called lactate. Now, let's just say that you need to keep the intensity relatively high. So give me some events that really start to take place in the 30-second to 2-minute window. 800. So my 800-meter runners, this would be basketball. This would be the 400. So here's my thing. You try to tell an 800-meter runner or a 400-meter runner that they're running at a low intensity and hide and watch when they come at you. They're not really moving at a lower intensity. They're just using a different fuel. But here's the question. Y'all are smart people. What if my 400-meter runner could deliver the same force as that person doing one vertical jump? It's not possible, which is why our bodies say you have to have a different energy form to make this happen. So we're using glycogen here. It converts to pyruvate. It converts to lactate. Now, the body says, hey, I got to keep the intensity up, but if I go this way, I've already reached my lactate threshold. You got to have me do something else. So what it does is it shuttles this pyruvate and lactate mixture into the mitochondria. And through the mitochondria, it gets this little oomph to kind of keep it rocking again, so that the intensity can still stay up to finish this 800-meter event. So it shuttles through here, it shuttles through here, it shuttles through here. Then, after it goes through, now again, it might only go through once on a 400-meter. It might have to cycle through twice on an 800-meter. But eventually, this delays this, but we still end up in this situation where we reach our lactate threshold. The trick to this is going through the mitochondria to pick up just a little bit more energy so that it can sustain a higher intensity longer. But we're still burning glycogen. This is slow glycolysis. This is fast glycolysis. I think in your book it actually calls slow glycolysis. It calls it, I think it calls it fast glycolysis oxidative. Okay, what's it call it? It calls it aerobic glycolysis. We're going to really start to talk more aerobic when we get to the other side of the line. But I want you to know, for the purposes of this class, it makes more sense for this to be called fast glycolysis and slow glycolysis. Say got it when you got it.
Got it.
Okay, now, the only thing that's different is that this lactate gets shuttled through what? The mitochondria, comes over here, and you still eventually reach your lactate threshold. Now, my question for you is, what if you're choosing to quit before you're done and not consistently reach your lactate threshold? Are you getting faster or are you getting slower?
Slower.
You're getting slower. You have to lactate threshold train if you want to get stronger. You have to do it. I recommend, you can't lactate threshold train 5 or 6 days a week. Why? You'll end up being overtrained. So I really recommend, we almost have to shock that system at least once or twice a week. You have to do that. You know what? And Corey, we talk about this even when it comes to aerobic training. When we get over here, if you do not push your lactate window, you're not getting stronger. Because even aerobic distance runners train over here. Because what we need to happen is we need to be able to generate more power and more force. And you generate power and force on this side of the line. Did you all take some time to look at that chart from chapter 1 that talked about the different sports that depend on each of the energy systems? It should start to make sense, the science behind the sports that make that happen. Does this make sense? Yes? Yes. Questions? No questions? Come on, it's a great time to ask a question. It's a great time to ask a question. Okay, what's my primary fuel for the phosphagen system? ATP. So when I burn ATP, I get creatine phosphate. It couples with ADP. They come together and make ATP again. It's like a little bucket. Does it fill up quick? Yes, fills up quick so you can go and dump it again. Now, you have to provide time for the bucket to fill up. Now, when we talk about work to rest ratios, when we talk about interval training, so much more of this will make sense. As a matter of fact, let's go ahead and look at that. This is a good segue. Go ahead and flip over to page, check this out. Jump over to page 60. On page 60 in your book, it talks about work to rest ratios. And it says that for every, and you guys remember, these are ratios. These are ratios. So you're going to have to think about this. This is like 1 to 3. This would be like 1 to 4. And you guys, it's kind of a 1 to 1 over here when we get to good training over here. So let's just say, if I'm having my athlete work in the phosphagen system for 3 seconds. Okay, so let's do ratio. If this is a 3, okay, how long is my rest period? 36 to 45 seconds. Okay, so what I need to do, that time to fill that bucket is 36 to 45 seconds. So if all of a sudden I'm asking that athlete, maybe I'm doing 2 vertical jumps. If I want the intensity to remain this high, how long do I have to give that athlete between sets to fill their bucket? 36 to 45 seconds. Do you understand about the ratio here? This doesn't mean if you're working 1 minute, you rest 12 minutes. Tell me you understand it's a ratio. Yes? So come over here and talk to me about this ratio. If I'm working my athlete for 20 seconds here, how long at a 1 to 3 ratio, how long do I need to give them to recover before they're ready to rock again? You got to give them a minute. Got to give them 60 seconds to be ready to roll again. Now, how many times have we seen athletes asking an athlete to go 100% or even up to 80% for 20 seconds, but they don't give them the minute recovery time to fill the bucket? Shh, you're on video, okay? So, Vegas laws apply. So, what we need to see is the body will respond to whatever you ask it. The body will respond to whatever you ask it. The body will respond to whatever you ask it. So what kind of people are you? Smart. So if you're asking this athlete's body to go again before you have let the bucket fill, what is the body going to say? Let's go. Nope, not going to do it. Because it physiologically can't if you haven't given it the appropriate recovery time. It's like you're trying to reinvent the ATP, CP, glycogen, carb. You're trying to reinvent the lactate threshold. It's wanting to do that, but it can't. Because you're not allowing the bucket to refill. The bucket has to refill. So come over here when you're talking a little bit more. You need a little bit more ratio. You need a little bit more rest on this side because you're going a little bit longer. So if all of a sudden I have an athlete, let's say we're doing 2 minute, 900 meter repeats. How much do I need to give that athlete if we're going to be going 2 minutes? I got to give them 8 minutes to recover if I want their intensity to be able to remain that high. For some reason, we're having coaches that are not paying attention to the science behind what the body can do and what the body can't do. You know, we're not asking the body to be efficient and effective. You ask, how efficient and effective would a horse be that ran on 2 legs? Not very efficient or effective. We have to realize that there is science behind what we're asking the body to do. The goal is to always improve your lactate threshold. And what you'll find is, if you're not following these laws of mass action and mass effect, you're not increasing your lactate threshold. So what are you doing to the performance of the athlete? Gosh, it stinks to think that we as coaches in this profession would be doing something with good intention that was completely non-science based. And yet we're training people to get slower and weaker because we saw someone else do it. You're better than that. This is the science behind the why the phosphagen system and the glycolytic system works like it does. So here's the plan. When we come back next week, we are going to rock out the oxidative system, and we are going to talk about the different kinds of training protocols that overlay this entire picture of this. If you have any questions, email me, call me. It kind of is cool if you want to call during my commute. I can talk. It's almost easier for me to talk through things with you than email back and forth questions. So have a great weekend. Hey, listen, if I were you, I would study some in chapter 8 this weekend. You got to go back to your trait anxiety. You got to go back to all of those different kinds of stress management techniques. You've got to do that so that you're not behind the curveball next week. Hey, I love being with you guys every day. God bless you all. See you next week.